Hey everyone, I hope you guys are doing great. So let's get started today's. For this session, we'll see how to store passwords securely in a database. What are the different ways in which we can store password in database and what are some of the best practices for passwords. So as you already know, we should never store naked or plain text password. So the idea is to either hash it or encrypt it or encode it first and then only store that value. So for the hashing, the password will be hashed using bcrypt hashing function to produce a hash value. Besides the input password, bcrypt requires a cost parameter which will decide the number of keys, expansion rounds or iterations of the algorithm. Bcrypt also generates a random salt to be used in those iterations, which will help to protect against the rainbow table attack. If you don't know about the rainbow table attack, I'd like you to go and research for the rainbow table attack, or if you want us to make the video, write in the comment section. Because of this random sort, the algorithm will give you a completely different output hash value even if the same input password is provided. The cost and salt will also be added to the hash to reproduce the final hash strings. So let's see how it works. So whatever password you have given, that value plus salt will be hashed and stored in the database, and when you want to compare it during the time of authentication, at that time the password plus salt will be again hashed and those two values of hash will be compared against each other, and if it is equal then the authentication will be successful. If it is not, then it will throw the error. So clients or the user provide the plain text password along with the salt, which can be randomly generated. It is hashed and stored in the database. So hash data in the database is a combination of password plus salt. Using cryptographic hash function is better than storing plain text password. Hackers are smart guys, and once they came to know the developers are storing hashed password, they pre-compute hash for large number of words from a popular word list or dictionary words. They create a table of words and their corresponding hashes. You should consider the three things while using a salt with password. The salt has to be different for every password you store. This is a quite common misunderstanding. Use a cryptographically secure random number generator, or timestamp can also be used. Choose a long enough salt. Think about the birthday problem. Remember that you do not need to use the same protection for each different accounts of user. Create different database accounts for different systems that access your database. Limit access on the database to only what they need using your inbuilt database grants. Don't give all the permissions to the user who is accessing the database. Store a DDS key inside a password manager class on your database. Use this to decrypt and encrypt value in your properties file. There is no need to store the password in a physically different table from the login. If one database table is compromised, it is not a large leap to access another table in the same database. If you are sufficiently concerned about the security and security in depth, you might consider storing the user credentials in a completely separate data store from your domain data. One approach commonly done is to store the credentials in LDAP directory server. This might also help with any single sign-on work you do later. So SSO can also be implemented with Azure AD, which works on the LDAP platform. Encrypted password. In some cases, passwords are stored in database after being encrypted by a reversible algorithm, such as route 13, mask encryption, or base64. If the attacker knows his password in a plain text or encrypted form, he can guess the logic of the encryption and will try to reverse it. If he succeeds, all passwords will be retrieved as quickly as they were in plain text, regardless of the algorithm complexity. Nowadays, we use MFA, which is multi-factor authentication. Even the best passwords have limits. Multi-factor authentication adds another layer of protection in addition to your username and password. Generally, the additional factor is a token or a mobile phone app that you use to confirm that you really are trying to log in. You can use SMS, email, or a mobile app for the MFA, multi-factor authentication. Many popular Companies such as Facebook, Google, Microsoft, these all are using MFA for their accounts. Length trumps complexity. The longer a password is, it is better. Use a 16 character whenever possible. Make passwords that are hard to guess but easy to remember. Never reveal your password to others. You probably would not give your ATM card PIN to any stranger, so why you give your username and password? Your login credential protect information as valuable as the money in your bank account. Nobody needs to know them, but you, not even the IT department. If someone is asking for your password, it is a scam. Use different password for different accounts. That is the way, if one account is compromised, at least the other account won't be compromised. Complexity still counts. To increase complexity, include upper and lowercase letters, numbers, special characters. A password should use at least 3 of these choices. To make the previous example more secure, bread and butter yum. Here you can see I have used uppercase, lowercase and special characters as well. Use a password manager. Password manager tools or password vaults are a great way to organize your passwords. They store your passwords securely, and many provides a way to back up your passwords and synchronize them across multiple systems. So thank you so much for watching today's video. Today we learned how to store properly in database the passwords and what are the best practices for passwords management. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.